Hi there, it's Mrs. Gifford, and I am here to talk to you and teach you about lesson 6.2 from our math book. So, first we're going to warm up with a add to problem. So here on my board, I've got Kelsey had 9 books. She borrowed 4 books from her friend. How many books does Kelsey have now? So, with this particular type of word problem, an add to problem, that means that we know both of our addends, but we're trying to figure out what our total is. So, if we're using a math mountain, that would mean that we know this number. So she has 9 books, and then she borrows 4 more, and we want to know what our total is. But something that might be helpful as you are doing these kind of word problems, just to keep track of what each of these numbers represent and what the question is asking you, is to label them. So if I look at my 9 here and I think about what does that 9 represent from my word problem, I know Kelsey had 9 books. So I'm going to just put a K under the 9 for Kelsey. Okay? And then 4, I've got to remember, what does that 4 represent? Well, in our word problem, it says she borrowed 4 books from her friend. So I'll put an F under 4 just so I remember that that's from the friend. Okay? So then if I add 9 plus 4, what does that give me? It gives me 13, and that's our total. And what does our total represent? Well, our question is how many books does Kelsey have now? So the total is going to be our total number of books. So that is an add to problem. All right, now this is an example of a take from problem. So this particular take from problem actually just kind of undoes what we did in the previous add to problem. So this one says, Kelsey had 13 books. She gave 4 of the books to a friend. How many books does Kelsey have now? Now I'm going to show you another method of how you can label your math mountain to make sure that it's making sense in your head and you're following along and understanding what the question is asking you. So I'm going to do my math mountain again. And this time it tells me the total number of books that Kelsey has. So I'm going to put 13 up here, but instead of writing total, I'm going to put another word that just helps me to follow along with the word problem. So I'm going to say 13 is how many she had. Okay? And then I know that she gives 4 of the books away to a friend. So just to keep track of what's happening in the word problem, I'm going to label this gave away. So she had 13, she gave away 4. So what am I going to put here as this addend? It's going to be 9 because we did 13 minus 4 to get 9. And 9 is how many she has now. So it's asking us here in the problem how many she has now. So then if you were to write this math mountain as a equation, a math sentence, you could write 13, oh, my whiteboard's moving, 13 minus 4 equals 9. And that's how you could solve that one. Now, something I want to make sure that we remember is that addition and subtraction are inverse operations. So, I'll give you the example here. So if we do 5 plus 7, we have 2 addends here. What is the sum going to be? The sum is 12. So since addition and subtraction are inverse operations, what could I do to undo this problem? I could do 12 minus 5 equals 7. So an inverse operation kind of means that the one undoes the other one. So addition and subtraction are kind of opposites of one another. Now, some of the problems that you're going to be doing today are what are called an unknown addend problem. So, as you might guess, those kind of problems don't tell you what one of the addends are. So, there's two numbers that get added up for the total, and it's only going to give you one of those numbers. Okay, so let's read it. So it says there were 90 girls and some boys in an after-school program. 160 children were in the program in all. How many boys were in the after-school program? So, one big clue word for you in an unknown addend problem is this word sum. So, if there's the word sum in one of your problems, chances are it's an unknown addend problem. Okay? So, there's a couple of ways that you can think about this problem. So go ahead and pause the video for a second and try to come up with an equation that will help you solve this problem. All right, so there are a couple of ways that you could have thought about this problem. So one way, the way in pink, you could have thought of it as an addition problem. So 90 plus what? I put a variable in here, so letter B is my variable. So 90 plus what equals 160, where 90 represents the girls, the variable B represents the boys, and the 160 represents the children. So then you would just have to solve 90 plus what equals 160. So if we think for a second, if I know 9 plus 7 is 16, I would know that 9 plus 70 equals 160. So my answer would be 70 boys. But you also might have thought about it as a subtraction problem, because subtraction is just the opposite or the inverse of addition. You could also solve it using subtraction. So where 160 represents the number of children, 90 represents the girls, and our variable B represents the boys. If I know that 90 from this 160 are girls, I know that the rest are boys, so I can just say that 160 minus that 90 girls equals however many boys we have left. So again, if I were doing 160 minus 90, if I know that 16 minus 9 is 7, I know that 160 minus 90 is 70. So my answer there is also going to be 70 boys. All right, so we've already talked about how we can use Math Mountains for addition and subtraction. So for this one, 5 plus 7 equals 12, but we also know that 12 minus 5 equals 7, and 12 minus 7 equals 5. But did you also know you can use Math Mountains for multiplication and division? It's true. So instead of addition, we're just going to use multiplication. So we know that 4 times 5 equals 20, but we also know since division is an inverse operation or kind of undoes multiplication, we can also know that 20 divided by 4 equals 5, and 20 divided by 5 equals 4. So let's try this with some other math facts that we know. So if we have, let's see, if we know what 6 times 3 is, we can make our little math mountain here. We know that 6 times 3 is 18, but that also tells us that 18 divided by 6 is 3, and 18 divided by 3 is 6. Let's try one more. So if I know that 7 times let's see, 7 times 4. I know that 7 times 4 is 28. I also know that 28 divided by 7 is 4, and 28 divided by 4 is 7. So those are just a couple examples of how you can use Math Mountains for your multiplication and division facts as well. All right, so just like we went over some of the vocabulary for addition and subtraction, we're going to do the same with our multiplication and division. So in multiplication, the two numbers that are being multiplied together are called our factors. And then the total that we get from multiplying two numbers together is called a product. So if I were to label my Math Mountain just like I did with my addition, I'll put my product up here, my factors down here, and I would label them. So factor, and product. Now, these words are going to come in handy because just like we did unknown addend problems with addition and subtraction, we are going to be exploring how to do unknown factor problems with multiplication and division. All right, so let's look at one of those unknown factor problems now. So here we have a toy maker has 36 boxes of toy trains to ship to 4 toy shops. Each shop will get the same number of boxes. How many boxes of toy trains will each shop get? So remember, if this is an unknown factor problem, that means that we know the total. So we know the total number of boxes that are going to be shipped out, and we know what one of the factors are. So one of the factors is this 4 toy shops. So we just have to figure out what the other unknown factor is. So go ahead and pause the video and see if you can come up with an equation or math sentence to figure out how we could solve this problem. All right, so just like with our unknown addend word problems, there are a couple of different ways that you might have thought about how to solve this problem. The first way could be through multiplication. So it's easy to kind of forget what each of these numbers represent. So that's why I kept labeling them. So I know that my 4 from the word problem represents how many toy shops there are. So I put 4 toy shops times the number of boxes per shop. So I put the variable b there equals the 36 total number of boxes. So then if you know 4 times what equals 36, you could solve that problem. Another way that you might have thought about it is by using division. So if you did, starting out with your total number of boxes that the word problem told you, you could do 36 total boxes divided by the 4 toy shops that they need to go to. 36 divided by 4 toy shops equals a b variable amount, this many of boxes per shop. So just like the addend problem, you could think of these kinds of problems, the unknown factor problems, in 2 different ways, in a multiplication equation or a division equation. All right, so now that I've got my 2 options of equations that I could use to solve this problem, I can still use my Math Mountain as one of my math tools to figure out the solution. So I know that 36 is my total, also known as a product when we're doing multiplication or division. I know that one of my factors is 4, and so if I just complete the Math Mountain by filling in the blank, knowing that 4 times 9 is 36, I know that the answer is 9 boxes per shop. And there you have it.